cases, they kind of figured out the combination it should be. You know, there's potentially 64 combinations, so there's redundancy there in the code. It all packs in. You know, they figured out that the two-dimensional, three-dimensional structure, how it all packs into this tiny nucleus. So then in the 70s, Fred Sanger, amazing guy, one of the only people to get 2 Nobel Prizes for first figuring out protein sequencing and then DNA sequencing. Figured out how to read it. It was originally done on these gels, and then they kind of figured out how to do it as, you know, fluorescent dyes and things like this. So the process kind of got better and better. And so by the 80s, they were figuring out, well, we can start to read this thing. Why don't we read the whole thing? And this was led by the Department of Energy. And it's a little known fact that the DOE, it was the DOE, like Los Alamos and the nuclear energy people who put the original money and had the original incentive to study this, because they wanted to figure out what the hell they did to the people in Hiroshima and Nagasaki and Japan. Like, eventually the NIH and other people took the lead on this, but one little discussed fact of the Human Genome Project was the nuclear people that kind of kicked this whole thing off. And so it kind of, you know, started slowly, gathered momentum, and then in the late 90s it suddenly became this big race. This guy here, Craig Ventnor, basically turned up at the big Biology of Genomes conference and said, everybody go home. Don't work on humans, like, I'm going to do this in 6 months. Like, you know, the mouse is really good for you guys. Like, you know, study the mouse, because I've got this under control. And so all of the scientists were just like, well, we've lost the human genome. It's going to become this like copyrighted, privatized thing. And so then the Wellcome Trust, they are a British charity that, again, like lucky chances, the AIDS crisis in the 1990s, they had all of the patents for the antiretroviral drugs and were absolutely swimming in cash. And all of the US researchers, most of the people were just like, we can't keep up with this Craig Ventnor guy. He kind of came up with shortcuts to do it this much, you know, faster. He didn't care about the quality of the genome so much. They were doing everything really methodically, and he was saying, I'm just going to shotgun this. All we want to do is like patent these genes. I'm just going to do it really quickly. And so, but the Wellcome Trust basically, John Sulston and this other guy got on a plane, turned up at the end of the conference and said, whatever happens, the Wellcome Trust will pay for this. Like, however, you know, don't worry, guys, we've got this under control. However much it comes, we will spend like every penny we have to keep this in the public domain. And so then the consortium went on. It was an international consortium. Japan did 7%. China. The reason Rob and I and Chris are here in Hong Kong is China stepped in, did 1% of the genome, and our employer kind of came out of all of this. And so, you know, this long time, you know, timeline of how it happened, but by the end of the millennium, it's pretty complicated. But like at the end of the millennium, they basically had a draft. It took them about 10 years and $3 billion to do one genome. But like, you know, that was the state of play 15 years ago. It's then been unbelievable what's happened since. So, you know, computer people, everybody knows, they all know about Moore's law, how microprocessors every 18 months kind of like double in speed, double in power. But genomics has pushed this by like orders of magnitude. Lucky breaks with the kind of chemistry, and so, you know, the Sanger chemistry that they did with the Human Genome Project did you know, work quite well. It was kind of following Moore's law and the improvements until about 2005, and then this